A few facts that everyone should know about avian influenza. As more and more cases of bird flu are reported, the world faces an immediate threat of a deadly pandemic. Pandemics, global disease outbreaks, are known to be like flash floods. They start abruptly, spread fast and cause a lot of damage all over the world. A few facts that everyone should know. What is avian influenza? As the name suggests, avian influenza refers to the infection caused by avian, bird, influenza, flu, viruses. These viruses are commonly found in intestines of wild birds, and these birds can carry the viruses without getting sick. However, the viruses can be pathogenic to domesticated birds like chickens, ducks and turkeys. Domesticated birds become infected through exposure to other birds or through surfaces contaminated by secretions and feces of the infected birds. These viruses are classified as low pathogenicity and high pathogenicity. Most strains of avian influenza come under low pathogenicity avian influenza, LPI, group and produce mild symptoms in the infected birds. Common symptoms are ruffled feathers, decreased food appetite, decreased egg production, sneezing and coughing. Many times, LPI may go undetected. High pathogenicity avian influenza, PI, has more severe symptoms which include sudden death, loss of energy and appetite, decreased egg production, respiratory problems, facial edema, swelling, poorly formed eggs and diarrhea. PI can reach a mortality rate of nearly 100%. What is H5N1 strain of bird flu? All flu viruses are classified as type A, B or C depending on their structural arrangement. Type A is responsible for lethal pandemics and is found in both animals and humans. Type B causes local outbreaks of flu. Type C is the most stable of the three, and infected people show only mild symptoms of flu. Type B and C are usually found only in humans. Type B and C are more stable than type A and are not classified according to their subtypes. Influenza viruses of type A are divided into subtypes, and the naming is done on the basis of two proteins, antigens, found on their surface, hemagglutinin, HA, and neuraminidase, NA. 16 types of HA and 9 types of NA exist. Thus, a total 144 combinations are possible. Thus, H5N1 is a type A virus and gets its name from HA5 protein and NA protein present on its surface. How do type of viruses cause a pandemic? Type of viruses are further classified into strains. These strains can continuously evolve into different strains. Their ability to exchange genetic material with other viruses and create new influenza viruses makes them unpredictable and difficult to fight with. Humans have to develop new immunity, antibodies, every time new strains are created. Viruses cannot repair genetic damage. Small changes known as antigen drift are continuously creating new strains of viruses. However, when genetic material from type of viruses from different species, say a bird and a human, comes together and merges, an entirely new strain is created. This is known as antigen shift. Humans have no immunity to such a strain, and the strain can spread rapidly, causing a pandemic. How is the virus transmitted to humans from birds? Usually, avian influenza viruses do not infect humans. Migratory birds act as carriers of these viruses and do not get affected by them. These birds then come in contact with domesticated birds such as chickens and turkeys and spread the infection to them. Domesticated birds may get the virus from contact with contaminated surfaces too. Once a virus infects domesticated birds, it can cause severe epidemic among the birds. Humans come in contact with infected birds or contaminated surfaces and pick up the virus. In the human body, this avian flu virus then undergoes an antigenic shift, combines with genetic material of a human strain of influenza virus and creates an entirely new strain of virus against which humans have little or no immunity. These genetic reassortments may also take place in the body of a third species, susceptible to both avian and human viruses, like the pig, where an avian influenza A virus and human influenza virus mix their genetic information and produce a new virus which might be able to infect humans. Why is H5N1 dangerous? The first reported cases of H5N1 infections were detected in geese in 1997 in southern China. A total of 18 human infections were reported and 6 of them succumbed to it. The infection spread quickly to poultry in Hong Kong. At that time 1.5 million chickens were culled in Hong Kong to keep the virus under control. The virus disappeared for a few years but resurfaced in 2002 in Hong Kong again. Since then, it has killed millions of birds in Asia and many cases of human infections have been reported. The persistence of this H5N1 strain of virus is a great concern for humans. Although the virus does not spread from birds to humans easily, the severity of the infection of H5N1 in humans is frightening. The virus has killed every second person infected by it. These cases were reported in perfectly healthy individuals who had no past history of infections. However, the greater concern for the world is the possibility that the virus may mutate, undergo antigenic shift, and create a form that may spread from human to human. Such a strain of virus may result in a pandemic, killing millions of people worldwide. Is consumption of poultry birds safe? Yes, it is safe to consume thoroughly cooked poultry products. The H5N1 virus is sensitive to heat and gets destroyed by normal cooking temperatures of 7100 degrees Celsius. If meat from poultry birds and eggs are cooked properly, the virus will be destroyed. Just make sure that no part of the meat remains raw or uncooked. How big is the risk of a pandemic breaking out? The world had to face a bird flu pandemic thrice in the 20th century. In 1918-1919, Spanish flu killed anywhere between 20 million to 50 million people, exact figures not known, including 500,000 in the United States alone. The Asian flu in 1957-58 killed 70,000 in the United States, and in 1968-1969, the Hong Kong flu killed 34,000 in the USA. Currently the risk of H5N1 strain leading to a pandemic is high. The virus is spreading fast to new areas and the efforts made to curtail it have proved inadequate. Domestic ducks have now become a reservoir for the virus. They are acting like a carrier for the virus. Their bodies carry the virus without showing signs of any infection. Infected ducks then release large quantities of the virus in pathogenic form in their excretions, spreading the virus to other birds or humans. This has made detection of the virus difficult, especially in rural areas. According to health experts, the virus has already met the first 2 prerequisites for starting a pandemic. First, it has attained a form for which humans have no inbuilt immunity, and second, it has proved pathogenic enough to cause serious illness and death in humans. The present risk of a pandemic is very high. The only factor that has prevented a pandemic so far is that the virus has not mutated into a form that would allow it to transmit efficiently from one human to another. Once such a genetic change takes place for the virus, a pandemic will be inevitable. The first signs of such a reassortment will be presence of the clusters of patients with flu symptoms, closely related, both in time and space. This would be a clear indication of virus having the ability to transmit from human to human. Currently no vaccine has been developed for fighting H5N1 strain. Simultaneous work is being done in many countries for developing a vaccine, but no success has been achieved. The exact virus that may cause the pandemic cannot be predetermined. Thus, mass production of vaccine before the pandemic starts is ruled out. The worldwide manufacturing capacity is inadequate to match the sudden demand surge during a pandemic. The best that scientists can do is to carry out a study and determine the smallest amount of antigen per dose that will provide sufficient protection and thus maximize the number of vaccines produced. What are the precautions necessary to prevent a pandemic? The logical first step is to control the disease from spreading among birds, but this seems a difficult task now. Bird flu has become a bird epidemic in many parts of Asia and is spreading fast. The next step is to prevent the disease from getting passed on to humans. People who come in close contact with birds, like poultry farmers, are advised to keep a close watch on the health of birds, Notify any sort of sickness in birds to the health authorities and avoid direct contact with sick birds in all cases. Ducks have become a reservoir for the virus and may not exhibit signs of sickness even if they are carrying the virus. In case the flu becomes a pandemic, most countries of the world will be affected. In such a scenario, the best preventive measures would be personal hygiene, avoiding crowded places and staying away from raw meat and eggs. A flu shot does not prevent bird flu, but it can protect a person from other forms of flu and avoid complications. Persons above 65 years of age, children, health services workers, people with chronic respiratory disorders, travelers to flu-affected countries and pregnant women may consult a doctor regarding flu vaccination. What are the symptoms in humans and treatment options for bird flu? A person infected by bird flu may have all symptoms of common flu-like fever, persistent cough, sore throat and body ache. Moreover, there is a high risk of complications such as pneumonia, bronchitis, eye and ear infections and severe breathing problems. Presently 4 drugs are used to combat influenza. The most effective drugs known for seasonal flu are oseltamivir, commercial name Tamiflu, and zanamivir, commercial name Relenza. Both of these are known to reduce severity and duration of seasonal flu, but they may prove ineffective if the virus is allowed to stay in the body for too long. Health professionals advise that treatment of FLU with these drugs should start within 48 hours of first appearance FLU symptoms. Oseltamivir and zanamivir fall in the neuraminidase inhibitors class. The surface protein neuraminidase breaks bonds between new viruses and infected cells. By blocking the activity of neuraminidase, these 2 drugs prevent the new viruses from being released. Another class of drugs, the M2 inhibitors, is also available, but viruses develop resistance to these drugs quickly and thus these drugs may prove ineffective in controlling pandemics. Amantadine and ramantadine are 2 drugs from this class. These drugs inhibit the activity of M2 protein, which forms a channel in membranes of viruses and thereby preventing the viruses from replicating. One should consult a doctor before taking any of these drugs as these drugs are known to have side effects in some cases. For example, zanamivir is not recommended to people having chronic respiratory diseases such as asthma.